concept of it. It makes it not so bad. But in a sense, we're just going to manipulate these things to make it look a little bit easier for us when we do this. So first thing I want to do is I'm going to go ahead and want you to do this as well. I want you to go ahead and let's just put some letters here. X, Y, Z, and I don't know, R. It doesn't matter. Okay. The triangle proportionality theorem, the concept is this. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides the segments into proportional lengths. So essentially what that says is it says that if DE, if line segment DE is parallel to line segment AC, so the middle segment is parallel to a segment out there. If those are parallel, then it divides the segments into proportional lengths. So then X over Z is going to be equal to Y over R. So it essentially says this. At that line, makes them two proportions. And you can put an equal sign in between them. Okay, so that becomes your division bar. That becomes your equal sign. Okay. And then the converse to the theorem is true as well. If X over Z is equal to Y over R, then DE, segment DE is parallel to AC. It just flips it around. Okay, if they're proportional, then blah, 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 blah. Okay, so that's that whole thing. It's proportionality. This over this equals this over this. And all the words really make it, again, more complicated than it needs to be. It essentially says that I can make a division bar there, and I can put an equal sign between them. Now, the key to all of this, and the easiest thing to do with all of this is to, if you can't see it, rotate your paper. I can't rotate the computer. I can't rotate my computer screen. It doesn't work like that with the program that I have. But if you take your notes, and if we look at this first example, take it so it points up. Then you just kind of draw a line, put an equal sign before them, and that's the proportion that we can put together. Okay, so like I said, I can't rotate that. I can't do that. But you can take your screen and you can rotate it. And if you rotate it, I can put a line right here. And then I can put the proportion together. I can put the proportion together. 12 over 14 is equal to 15 over x. So this over this equals this over this. If I flipped it around and said 14 over 12 is equal to x over 15, notice that if I cross multiply, it's 14 times 15 on this one, and it's 14 times 15 on this one. It's 12 times x on this one. It's 12 times x on this one. It's not changing anything. Okay? As long as the segment you're looking at is consistent, 12 over 14, so the small part to this part equals the small part to this part. Part over part equals part over part. I could even, if I wanted to, I could go 14. If I like to see it like this, I can go 14 over x equals 12 over 15. So this over this equals this over this. It's the same thing. Again, if you look at the diagonals, it's 14 times 15. Okay, so as long as you're consistent with where you start, what your numerator is, and what your denominator are, there's vast ways to do these. Okay? Essentially comes down, if you set up a proportion, you set it up correctly, you're going to get the right answer. So mathematically, we take 12 times x. That gives us 12x you find a calculator, because I don't know what 15 times 14 is. It's 210. So you get 12x equals 210. Divide by 12. 210 divided by 12. 17.5. That's the length of that segment. 17.5. Now you do need to notice it's segment over segment equals segment over segment. It's not segment over whole equals segment over whole, which is also true. But that's not what it is. It's segment over segment equals segment over segment. So if we look at number 2, you have to turn it around to point up. Okay, if you have to rotate it so that points up. Okay, I can put my line right here. So my ratio is going to be x over 18 equals 56 over 21. Small triangle over the bottom part equals small triangle over the bottom part. Now again, this only works if these two lines are parallel. If those two lines are parallel, this don't work. If those two lines are not parallel, this does not work. Those lines have to be parallel to each other. Cross multiply. 21 times x is 21x. 56 times 18 is some really big number. 1008. Divide both sides by 21. To find the value of x, and x is equal to 48. It's part over part equals part over part. It has to be part over part equals part over part. If we look at question number 3, question number 3 now doesn't have parts and parts. It's got x and 36. Okay, so the small part is x. The big part is 36. But now I need to know this part right here. I know this part down here is 45. I know this part right, the whole thing is 55. So what's this little part right here? 45 plus what is 55? 10. So that part is 10. 10 plus 45 is 55. So then the ratio I have here is 10 over 45. Part over part equals part over part. Cross multiply. X times 45 is 45x. 36 times 10 is 360. Divide by 45. 8. You get x is equal to 8. And that's your solution. Go ahead, set up number 4 real quick. See if you can set up number 4. Oh, I'm sorry that happened. I'm glad it was only your knee. I mean, of all things, at least it was only your knee. It could have been a lot worse. So x over 7. I used to always do the pointy one first. What's in my numerator? 26 is in my denominator. What's in the numerator? What plus 6 is 27? 21? Everybody see how I got that? It's 27 minus 6. So 6 times x is 6x. 7 times 21 is 147. 147 divided by 6. 24.5. Were we able to set it up okay? All right, concepts don't change. The difficulty of the math does. Okay, so look up at the vertex. Let's set this up. So if I put 30 in my numerator, what's my denominator? Could be, but let's just go down the side. X plus 7. So 30 was in my numerator, so 25 has to go in my numerator. What's the denominator? 15. Okay. So we just set it up, just go along the sides. Set your proportions up along the sides. We'll do this one together. So we've got 25 times x plus 7. That's this cross product. Our other cross product is 30 times 15. Remember, we distribute. 25 times x is 25x. 25 times 7 is 175. 30 times 15 is 450. Solve. What do I do next to solve that? I've got to isolate the variable. So I've got to get the 175 to the other side of the equation. So add it or subtract it? Subtract. So I'm going to subtract 175 from both sides. That leaves me with 25x equals 450 minus 175 is 275. Divide both sides by 25. How many quarters are in $2.75? 11, I think. Yep. So x is equal to 11. And you're done. Questions with that one? All right, go ahead and set the next one up. Just set it up and then we'll solve it together. Got it set up? What did we put as our numerator for the first one? Somebody just tell me what you did. There's lots of ways to do this. Somebody just tell me what's your numerator. Pedro, what is it? Just tell me what you put.
I put 6 over x minus 1.
Okay, we could do this. This is okay. If we do 6 over x minus 1, what does that have to equal?
21 over 3x plus 1.
3x plus 1. Okay. Let's leave that there for a second. I think it's okay. Did anybody else put something different? Whoa. I don't know what happened. Oh, I do know what happened. I'm back. Did anybody else do anything different? Did anybody put 6 over 21? Okay. If I put 6 over 21, it's going to be x minus 1 over 3x plus 1. Look at the cross product. So the cross product's the same. 6 times 3x, that looks the same to me. It's 6 times 3x plus 1. This is 6, so that works. Did anybody put 21 on the top? Nobody put 21 on the top? If I would have went 21 over 6 and 3x plus 1 over x minus 1. See how the cross products are always the same? As long as you're consistent with what you do, you're going to be okay. Okay, that's kind of the nice thing about this stuff is as long as you kind of do what's proportional, you're going to be all right. Okay, so let's solve. So this is 6 times 3x plus 1 is equal to 21 times x minus 1. Distribute. 6 times 3x is 18x. 6 times 1 is plus 6. Equals 21 times x is 21x. Minus 21 times 1 is minus 21. We're gonna got to get the numbers and everything on the same side. So I'm going to go ahead and subtract 6. I'm going to run out of room here quickly. That's 18x equals 21x minus 27. That's right. Now I've got variables on both sides. So I'm going to subtract 21x's from both sides as well. So that's negative 3x equals negative 27. Divide by negative 3. You get an x value that's equal to 9. There's lots of different ways you could have did that. You could have subtracted 18x from both sides up top. There's lots of different ways to do this one. But in the end, you're always going to get an answer that's x is equal to 9. Okay? So is everybody comfortable setting up the proportions? Again, that's the geometry part of it. Okay, that's the 3 out of 4 points on an assessment, is you being able to set up the geometry part of it. Okay, the other part of it, obviously, is being able to solve. Okay? Any questions with the triangle proportionality theorem? Are we okay with that? Okay, so what you're going to do today, that's the triangle proportionality theorem. Tomorrow, we're going to talk about the parallel lines and proportional parts. We'll talk about that piece of this tomorrow. What do you have to do for tonight? You're going to look for this page, this document right here that says this is a 2-page document. On this document, you are only going to do the front side of it. So here's what you have to do on the front side of this. You only need to do questions 1 through 7 today. Tomorrow we'll do the back side of this. Directions are this. You need to set up the proportions for all 7 of them. So you need to set the proportions for all 7 of them. And then I want you to solve questions 2, 4, and 7. So you have to set up the proportions for all of them. You need to find the value of x for questions 2, 4, and 7. Set them all up. Find the value of x for 2, 4, and 7. You have 30 minutes, roughly 25 minutes. Should be plenty of time.